राकेश सर स्टार्ट करें हम लोग.
हाँ सर जी.
Okay, so just wait. Okay, so very good. So today he is deliver his talk on the topic of fuzzy logic and its applications. Professor Rakesh Nayak is working as a professor in the Department of CSE VEC Warangal. He completed his PhD from Brahmpur University in year 2013. He has more than 20 years of teaching experience. He has more than 30 publications in international journals. He has published 2 books. He is a life member of several technical society like CST, ISTE, AING, and associate member of Institute of Engineers. He is in editorial board of several international journals. He has taken up several responsibility like enforcement officer for AP MCAT examination, served as a MTech coordinator. He served as a resource person for several national and international workshops. So I request Dr. Nayak, please share your screen and start your presentation. Thank you, sir.
Thank you, Vijay sir. Good morning, everyone. We are going to discuss a topic that is mostly in workshop like this, like where people are discussing about AI and artificial intelligence and all this. This topic is given little less preference. Okay. Am I audible, by the way?
Yes, sir. Audible. Please share your screen, sir.
Yeah. Sure. So, so we are taking up a subject that is called fuzzy logic. So can any one of you can say what is the application of fuzzy logic? If you can, I mean, feel like. Gaming? Is my screen visible now?
Yes, sir.
Okay. Now, can anybody say, Vijay sir, was just one more thing. As I'm not looking at the queries, no, people must be posting. I'm just looking at sharing the screen and look at the screen.
Okay.
So kindly,
If there is any queries in my chat box, I will let you know, sir.
Yeah. Just please.
Okay.
So, uh, can anybody say me what are the applications area where we generally use fuzzy logic? Is it possible? Can I get some kind of a feedback so that I can start? To be honest, there is no such area where you can leave fuzzy logic nowadays. Okay, you name it. You name chemical engineering. You name it mining. Whatever you feel like everywhere some kind of fuzzy logic is required, because either when you are doing some kind of business kind of thing also, whenever you are doing some kind of a activity, either you are doing decision making or you are optimizing most of the time, isn't it? So in both the cases fuzzy logics are important. Okay, and you will not believe fuzzy logic is given by what, Jade in the year 1965. Can you believe? The topic is, born in 1965, and now we are in a position to understand it and try to implement it in 1980s, like 75 to 80. People didn't work much. It's a dry season for artificial intelligence. So that's why people didn't talk much about this fuzzy logic topic. And in later on stages, nowadays people are talking more when artificial intelligence and then data science, all these things coming into picture, and people want a quick kind of a response from them. Okay, if a manager is there, let us say A business organization is there. The manager want a decision immediately. It is not the era where people will be taking the data, then they will be doing some kind of calculation. It will take a month of time, and then by the time the decision is taken and it is being implemented, maybe the business scope will be gone by then, or maybe there are many more competitors comes for that particular business. So it is not an era. We need, and it is a era of computers and artificial intelligence. So obviously, fuzzy logic plays a very vital role. Okay, and now you can realize in 1965 it is developed by Jade, and it is now 2020. Mostly people have started working on artificial intelligence in late 90s. Okay, so the importance of the subject is tremendous. Okay, now basically, to be honest, what the things are, like it provides a mathematical kind of a technique or mathematical tool, you can say, that will give you some kind of a, linguistic construct. Whenever you say something, it is not like a something is in our general day-to-day life. We generally don't talk about 0 and 1. It is not like switching on and switching off every time, isn't it? When, let us say, think about a scenario that you are driving your car, and for what purpose you use the brake? To stop the car? Yes, yes, to stop the car. But if you press the brake immediately, what happens? You may meet with an accident, boss, isn't it? So the brake is a system that is used to slow down as well as to stop the car. So how much pressure you are putting on your brake pedal so that it will reduce the speed gradually and it will come to a stop position, isn't it? So it is not a 0-1 kind of a system. It is not a kind of a system. You switch it on, light is on, and which you switch it off, light is off. It is not like that. Every system in our life is switching on and off. Maybe it is growing gradually, maybe it is coming down gradually. Think about a person. Let us say, think about what coldness. Let us say I'm having a kind of a, okay. Let us say this is my 0 degree, and let us say this is my, let us say minus 0.5, minus 5 degree, or minus 2. Let us say this is let us say 35, or in Indian context, let us say 45-degree kind of thing. Then for us, maybe 12 degree or maybe 23 degree is kind of a cool environment, we can say. The same thing is not true for a Western countries. Let us say somebody is there in Canada, then 1 degree, 2 degree to 10 degree is their normal kind of a atmosphere. So whatever is cool for you, maybe that is cool for somebody else. Maybe it is cool for somebody else, isn't it? And whatever is hot for you, maybe it is too hot for somebody else, isn't it? So that's why we generally plot the graph in the form of a triangle. Okay, let us say, imagine a scenario that, let us say, you are saying 0 degree as your, let us say, cool. Then obviously -1 or -2 here will be cooler, and this is, let us say, somehow, let us say 10 degrees centigrade. Then this is maybe like little bit less cooler. Okay, if let us say somebody is saying, let us say somebody is saying this is -2, if this one is -2, then less than -2 is, let us say, beyond that it is coldest kind of thing. So I can, my graph or the representation I'll do in that way. Okay, so it means what? all the linguistic kind of thing, whatever are there in our day-to-day life, everything can be represented in the form of what? Fuzzy logic. When we are saying something is like a tall, taller, tallest, or short, all those things, whenever we are trying to use it, all those things are a part of what? Fuzzy logic. Okay. What it does is generally provides a interface structure that enables the appropriate human reasoning capability. That's what I'm telling right now. Reasoning capability. How you can say? By taking some kind of your experience. Based on your experience, your reasoning will be built. Your reasoning, you will be having that capability. Whoever is sitting nearby you, maybe he is having more reasoning capability, or maybe he will be having less reasoning capability. Whatever is cool for you, it may not be cool for the others. Let us say you are right now switching on a fan, and the fan, let us say, is running at, let us say, at a speed of 2. Now it may be sufficient for you, but somebody who is coming from outside, from hot sun, then it may not be sufficient for him, his point of view, isn't it? He may ask that you kindly speed up the fan. So the basically the reasoning that you do, human do for a particular thing, uh, based on that we take a decision. We take on a decision. Okay, like now, just I told you the example of a fan, that the fan is still running at number 2, at speed 2. But the thing is, when somebody comes from outside, his feeling of hotness, maybe the speed of the fan may not be that sufficient down, isn't it? So that is what is fuzzy logic. It means you can give some kind of a linguistic construct to our general day-to-day life kind of thing. Okay. So basically, when you think about Boolean logic, Boolean logic gives you a sharp distinction. Sharp distinction. It may be either true or it may be either false. Okay, either it is white or it is black. There is no in between something called gray. And as I given you example of a car braking system, it is not always that you use it 0 and 1 kind of a system. You may use some kind of a system where you need to apply something gradually. Okay, so the fuzzy logic basically reflects what? How people think. As I've given you example, what is the, speed of a fan? Speed of a fan, it may be sufficient for you, but may not be sufficient for the person who is coming from outside, from a hot sun. Okay, so what does fuzzy logic does? It is a mathematical principle for the knowledge representation, and reasoning based degrees of membership. Now one more term came, that is called degree of membership. How much belongingness is there? But from this example you will be getting, like uh, the belongingness of black, the belongingness of black here, uh, let me show you the belongingness of black here. The belongingness of black here is 0. There is no black, but the belongingness of similarly the belongingness of white here is 0, isn't it? The belongingness of black here is, it fully belongs to this, but belongingness of white here is fully 1. So either the system is either 0 or 1. But in a fuzzy system, it will not work in that way. In this area also some kind of black is there. In this area also some kind of black is there. In this area also some kind of black is there. In this area also some kind of belongingness of black is there. In this area also some kind of belongingness of black is there. So how much it belongs, will give you a idea of how much it is going into that particular set. In that particular set, how much it belongs. Let us say we are saying that the person is tall, and if you feel that somebody who is 6 feet tall is, you will say tall, then and if you are saying let us say 4.8 feet is short, then somebody who is there in 5 feet, he is not tall. He is not tall. Huh? No, he is tall as compared to him, isn't it? He is tall as compared to him. And this fellow who is 5 feet tall may be short as compared to the fellow who is 6 feet tall, isn't it? So, if something is there, then we need to decide how much, if tallness is the criteria that I want to talk about, then what is the belongingness of the tallness of that particular person. That is what I'll say is called membership. That's what I'll say, something called a membership. Okay. So here, when we talk about, as I told you, this is my Boolean system. As I told you, this is my Boolean system, and Boolean system works with 0 and 1. But this is multi-valued logic. It starts with including 0 and 1. How many numbers are there? There are infinite numbers. So it means till now whatever we discussed, that is like Boolean logic, is a subset of Boolean logic, is a subset of your fuzzy logic. Okay, because it carries only zeros and ones, and it carries everything in between zeros and ones. So whatever Boolean logic we have discussed from still our school days, since our school days, is a part of this particular system. That is our fuzzy system. That is our fuzzy system. Okay. So the degree of belongingness varies. Okay, the degree of belongingness varies. Now somebody puts break like this, it will happen in this way only. That's all. That's all. So you cannot put your brake, use your brake. If by chance your your vehicle stopped, this is what is going to happen. Because of inertia, you will be thrown out of the vehicle. That's what. So brake need to be used, judicially, and it is not like 0 and 1 system, isn't it? Then when we talk about fuzzy logic, then what kind of characteristics a fuzzy logic must have, we have to discuss that also. First thing is, it is basically flexible and easy to understand and easy to implement for any kind of machine learning technique. As I told you, in our real life, we very frequently we don't use Boolean system, except for some systems like switching on and off the light, isn't it? Again, if we'll talk about intensity of the light, again it will become a fuzzy system. So in our general day-to-day life, we'll be using, and we are using, knowingly or unknowingly, all the fuzzy systems. And when it comes to machine learning, obviously, machine supposed to accept the thing which is nearer to the application, which is nearer to the human being. So that's why it is quite flexible and easy to implement. Okay, and it helps to mimic the human thought. As I told you right now, applying the brake of a particular a vehicle is about the human who is in the position only. Okay, in the position, who is there in the position, he will be applying back the brake based on the situation. If somebody is going in a highway, why he should break, press his brake unless and until he is, reaching the destination, or and he will slow down his system if some obstacle comes in between. Otherwise, no need of pressing his brake, and there is no need of press, and that too, he will press his brake judiciously, not like Boolean system. Okay. Similarly, the logic may have two valued representation, two values system, but application in between kind of thing will always be fuzzy system. Outside, it may be looking like that what it is a Boolean kind of system, but inside working will be fuzzy system. Let me give you an example. Let us say somebody has to take a decision. Okay, let us take. Let us say you have applied for a leave. You have applied for a leave. So there are two things: granted, or it will never be granted. It is not granted. When it comes to you, it is a Boolean system. It is a Boolean system. Either the leave is granted or not granted. But who is putting the signature on your leave form? That point of time, you need to think how many leaves already you have availed, whether already there is a circular issued that you should not take a leave on this and this date, and still you are applying for a leave. Okay, and whether some important work is there, whether leave should supposed to be granted. So the leave granting authority, he need to think, and when it is coming to a decision making kind of thing, always there is a fuzzy system in between. So for you, when you applied a leave, it is a Boolean system. But who is doing on the background? The person who is granting the leave, he is taking a decision based on several criterias, and he is saying the leave supposed to be granted or not granted. Okay, or he will grant the leave, but he will warn you that you have already exceeded the leave, or you are about to exceed the leaves, number of granted leaves. So all these criteria are there. Okay, so that's why from outside it may look like that the system is Boolean, but inside it is a fuzzy system. Okay, let us say you asked let us say some of you are married and some of you are having grown up kids also. Your kid asks you some money, so do you blindly give the money? No, generally we ask that for what you need the money. Now you are taking a decision based on the reasoning, based on the reason your kid is saying. You are taking a decision saying that whether that much amount is granted, or that much amount you will give, or maybe with a lesser amount you can give, isn't it? So all those things are fuzzy system, and that is highly suitable for uncertain and approximate reasoning. Uncertain and approximate reasoning, like that example that just now I have given. When your kid asks you for money, the system for him is uncertain. Okay, or he can just approximate kind of thing. My father will give me or not give me. There is a chance of giving me the amount. Maybe he will not give me. It is a kind of uncertainty kind of thing, isn't it? In those areas also, you can apply your fuzzy system. Similarly, fuzzy logic views interface as a process of propagating elastic constraints. When the constraints are not fixed, when the constraints or restrictions are elastic, can be strengthened, can be loosened. In that situation, also fuzzy logic can be used. Okay, it also allows you to build nonlinear function, and it also used to build the complete guided expert system. Okay, so these are the basic characteristics that you are having for any fuzzy system. And that too, when you know when to use it, you must know when not to use it also. Okay, when you don't find a convenient way to map a input space to a output space. When you don't know if this input I'm giving, what output I'm expecting, fuzzy system is not advisable. Okay, so whenever the system you can generate by your general common sense, by using common sense, if you can find a system, you should not use fuzzy systems. Okay, so these are the areas when you should not use any kind of fuzzy systems. Okay, now so possibly I have given you little bit of insight about what kind of a system it is. Now let us see the architecture of it. So any fuzzy system having four different building blocks. The first one is the rules based on which you will be generating the intelligence. Always there is a, I mean, whatever input there you are giving, always the input is a kind of a binary kind of system. You are giving a value to it. You are giving a value to it. And as I have told you, the fuzzy system lies between 0 and 1. So you need to make the system within 0 to 1. So I'll say I'll use a fuzzy fire that will be doing that particular input, that particular thing. And the crisp input is converted to fuzzy input by a fuzzy fire. Now you are having the rules and you are having the fuzzy inputs. And based on this two, you are having the intelligence applied. These two will be applied on the intelligence, and the output that you will be getting is a fuzzy output, and from the fuzzy output you will be using defuzzifier. Defuzzifier will be converting the data that you got within 0 and 1 to 0 and 1 to 0 and 1. Okay, I'll give you one example, but let me describe this a little bit more. So what is rule based? Rule based is a certain all the rules, and the rules all are all of the type if then kind of type, if then kind of type, and these if then condition will help you to take a decision, that helps it in making you decision. Okay, and the fuzzy theory provides various methods for designing, turning the fuzzy controller. Okay, this is about what the rules that you are using. So most of the time you are using a if then kind of a rule that is applicable for a rule based kind of thing. Okay, the next thing is about a fuzzy fire. Fuzzifier, what it does, it helps in converting the inputs. How it will convert? It will take all the crisp data to a fuzzy data, fuzzy cells. Okay, as I told you, it will try to convert all the data that you are having to the fuzzy data, like the room temperature and all these things. Okay, pressure and all these things. Right. The next thing is about intelligence. What is intelligence? You got the fuzzy data, and you already have the rule based. Already you set a rule for this, and based on this rule based and fuzzifier, this intelligence system will make a decision on the basis of percentage of matching, and it will determine which rule to implement according to the given input field. Okay, it will be determined. Okay, and the last step is, so the output of this becomes a fuzzy output. Okay, and the last step is you are going to have a defuzzifier. Okay, defuzzifier. So this defuzzifier will convert the process that the data that you got in the form of 0 to 1 to either in the value of 0 or 1, in the value in the form of 0 or 1. Okay, now when there are many rules we are having that will convert to fuzzy. Let us say, let me give you one example. Let us say fx is a function. Fx is a function. Okay, fx is a function, and this function is saying the speed. Let us say I am saying this is a kind of what I'll say, kind of 0 and kind of 1. If the speed is, let us say x is less than 40 kilometers per hour we are going, then you will say that it is slow or a 0 kind of thing. Okay, and if it is 1, let us say x is the speed. If it is, let us say greater than 60, greater than 60, or let us say greater than equal to 60, then you say it is a true speed. Then what you can have in between, what you can have in between, huh? You can have, so this data is this data is for x. This data, this x value is for what? Data which is what, greater than 40, greater than 40, and which is less than what you can say 59. Okay, less than or equal, less than 59. So between these, you need to say what is the speed. So how can you say, um, let us say how can I define my speed? I'll say 50. Let me say what uh, I'll deduct the speed and divide it by 10, and from what I'll deduct, let us say I'm dividing it for, let us say 50. Okay, for 50 speed. Now let us say I'm going at, let us say 42 speed. So can I say it is slow or zero? I cannot say. It doesn't comes to this range also. So what can I do? 50 minus 42 divided by 10. So the speed of this, you can say is like what it is, like 0.8, isn't it? 0.8. Similarly, here the speed, let us say, or I can do in a reverse way also. Uh, Okay, so such kind of a rule I can have. So the belongingness, that 42 speed is I mean having a belongingness of 8. So 42 is the discrete data I'm supplying here. Is it crisp data I'm supplying here? And 0.8, it is a, I mean a particular rule. This is the rule that I have applied now. This is the rule that I have applied now. Maybe the rule changed. Okay, so I can say 0.8 is the membership of speedness of the particular vehicle. Okay, so now 42 data as a crisp data, I converted into a fuzzy data, that is giving me, according to this formula, it is giving me 0.8. So 0.8 lies between 0 and 1. Okay, so this is the first step I need to do. Okay, and if 0.8 comes to this particular intelligence, and from the rule base I can take some kind of a decision based on the rule and based on the verified data I'll be taking, I'll get to a conclusion saying that whether this is a speed or more speed or less speed, and depending on that I'll say if it is speed, enough speed, I need to apply brake or I need to slow down. So application of brake will save me some kind of a data here based on again some formula, and I'll be applying my brake here depending on the intelligence data or the fuzzy output data that I'm getting out of this intelligence system. Okay, so that's how I'll be applying my brake. Okay, so this is how basically the fuzzy system works. Okay, basically people do confuse what is fuzzy and what is probability, because probability also comes between 0 and 1. Probability also comes between 0 and 1, and fuzzy also I am saying that it comes between 0 and 1. So fuzzy and probability are same. They are not same, my dear friends, because probability says me certainty and likelihood, and fuzzy said me the belongingness, or let us say vagueness or ambiguity. Okay, how much ambiguous it is. It means what? Fuzzy is a degree, is a says me the truth, degree of truthness. But what the mathematical model of probability say me about what? Ignorance. Let us take one example here. Let us say some water, somebody has given you a glass of water. Okay, a glass of water. Okay, this is up to this, it is filled, water is there inside. Okay, now somebody is saying me that there is a 90% chance, 90% chance that this water is can be drunk. Okay, and somebody says 90% means what? 0.9, isn't it? Probability of 0.9 that it is somebody will drink it. Okay, and if I am saying the same thing, that 0.9 chance, this is a probability of this water is drinkable, and 0.9 when I am saying in the form of fuzzy system, that it means it indicates that 0.9% or 0.9 people will drink that water. Okay, so that is a kind of a vagueness that you are not sure. Okay, so this is how the probability and your fuzzy system differs. As I told you, the Boolean system tells me about 0 and 1. So when I will say Ram is tall, then obviously it will be having a crisp boundary. Obviously it will be having a sharp boundary. Either it will be yes or it will be no. There is no in between. Okay. So for widely digital systems, we use this kind of Boolean system. All the digital system basically works with Boolean system. Okay. But when it comes to our what fuzzy system is, as I told you, it takes the value in the form of linguistic. So it can be like very tall, not very tall, or simple at all, not tall. All these system will be coming. So basically, the boundary is not sharp. The boundary is not sharp, and we generally use somewhere where fuzzy controllers are used. What is fuzzy controllers? What is fuzzy controllers? That depending on the input, it will decide the output. Okay. Now, let us say it is having an ambiguous boundary. It does not have any crisp boundary. So such kind of things we are having on with what fuzzy system. Okay. Now, there are many applications. You name it, and you name the area. Or in all these areas, you can apply. Okay, we think about a air conditioner also. A fuzzy system is there. It will take your room temperature. It will take a decision, and it will take a decision to what switch on the compressor or not. Okay, and if the temperature is low, enough low, it's supposed to switch off the your compressor. Okay, so you name the application, you name the area, everywhere fuzzy systems are used. Whenever there is a decision making kind of thing, wherever there is a optimization kind of thing, in all those areas, you are using fuzzy systems. You are using fuzzy systems. Okay, so I think I have told you regarding what actually is a fuzzy system. Now let us take a few operations that we generally perform under fuzzy system, and if time permits, I'll tell you regarding how to code a few of them using Python. Okay. Now, in our general classical operations, what we are having? We are having union operation, we know it. We are having intersection operation. We are having complement operation. We are having difference operation. So all these operations are there. Okay. Then we are having on this we can apply commutative property, associative property, or distributive property, what idempotency property, identities, transitivity, involution, law of excluded in middle, then a law of contradiction, De Morgan's law. All of them are we know how to use it. Now let us see how can whether these can be, as I'm saying, the fuzzy system is a superset of a binary system or a Boolean system. Can all these be applied? Can all these things be applied? Okay. So basically, let us see few of the operations that we are having. So as I told you, you can give such kind of a, categorization you can do like what tall, short, or very short. Okay. Now in fuzzy system, I have already told you this. In crisp system, always the system goes from what zero directly to one. Either it will be a zero or one. But in our general day-to-day life, it never goes like that. If it is zero and if it is one, then the value in between can be anything between 0 and 1. The value can be anything between 0 and 1. Okay. Now, so the value, so the elements that takes the value between 0 to 1 basically is what the fuzzy set. Okay. So basically a fuzzy set denoted by this cap, and some people generally like in some books they like the tilde below the particular set. Okay, so it is not a very big thing. Now let us do some kind of operations. Let us try to understand some kind of operations. What operations we can have? We can have union operation. We can have union operation. How we perform a union operation? So as in our general set, what we generally have is if X is an element and that is belongs to set A, okay, and if I'm saying or X is an element belongs to set B, then I can say X belongs to A union B. X belongs to A union B. The definition is quite same here also, except something. Except something. What is that? We are going to take something called maximum. We are going to take maximum. I'll say you what it is. Okay. So maximum of the element X, X's membership in set A. Similarly, the element X's belongingness to set B. Out of these two's belongingness of element X, I want to take the maximum. This is how I'll be finding what? OR operation or union operation. Similarly, for intersection operation, obviously in general set theory I use AND operation. In place of this OR, I use AND, right? I use and the symbol I use is intersection. Same thing here also, but then sometime people write what membership of element X in what AX of AX dot BX. People sometime write like this, or they sometime write in place of this dot they write intersection also. But what the meaning remains, sorry, this is okay, so the meaning remains the same. So how generally we will find for the element X in set A, what is the membership? Let us say this is 0.2 is the membership. Okay, for element X in set B, what is the membership? Let us say 0.6 is the membership. Okay, then out of these two, I'll take the minimum. So A intersection B in the fuzzy set system will become 0.2. Okay. Similarly, I can have some kind of complement operation. As in set theory, you are having what? Universal set minus X you do. The same thing is as the universal set or the bigger set is here 1, bigger set is 1, the maximum value that you will be having is 1. So 1 minus membership of the element x in the set A. If you are going to find that, let us say if you are having membership in a particular set, x has belongingness, let us say 0.4, x has belongingness of 0.4, then its complement will be 0.6. Its complement will be 0.6. Okay, so this is how I'm going to find my calculations. Okay, so all I can have commutative law. I can have, so this commutative laws, you know. Similarly, you will be having associative laws. You will be having distributive laws. All the laws that is satisfied with general system, general binary system. All the laws are applicable except for one. Except for one. Except for one rule, accepting all the rules, and the rule I'll be saying at last. Okay, I'll be saying that rule at last. Now, as I told you that if I'm saying I'm talking about membership, then the membership of a particular element x in the set A, I'll denote it by the what, mu, and it will always belongs to what, 0 and 1, including 0 and including 1 also. Okay, so I generally represent a fuzzy system in the form of a triangle. Okay, as I told you, why, because it is a kind of belongingness, it is a kind of belongingness. So this value to the set A, how much it belong? It belong 0.2, let us say 0.2. Similarly, this value belongs, let us say 0.4. Okay, in that way, the value ranges between 1 and 0. So this is how we generally show a fuzzy system in the form of a triangle. In the form of a triangle. Okay. We are going to do some mathematical problems also. Okay. Now let us do some problem. How to represent the union operation. If let us say we are having something called A union B, then it is nothing but membership of element X in set A or membership of element X in set B. So how generally we found? We generally represent it like this. So the same example that I have given you, that I need to take maximum. I need to take maximum. Okay. Similarly, I'm having something like intersection operation. I'll be using and this shows this part belongs to both the set, this set as well as set B, set A as well as set B. Okay. Similarly, I'm having complement. As I'm saying that complement is nothing but minus from 1. So it means what? If this is the value, if I'll add this value and this value correspondingly, it's supposed to give me 1. Okay. So what are the value that I'm telling? Let us say membership function of a particular value x is 0.8, then 0.8, then its complement will be membership of that particular value will be inverse will be 0.2. And from how you got it from 1 minus 0.2. Okay, 1 minus 0.2. In this way you are going to find the complement. You are going to find the complement. Okay. Now, so this basically is the only one operation. This is the only one rule that doesn't satisfy. That doesn't satisfy with the fuzzy system. That doesn't satisfy with the fuzzy system. Okay. Now let us do one example so that you will be able to understand it, and then I'll explain you I'm not going to write the code using the actual what you say fuzzy methods that are available, but I'll write a simple code that you will be able to understand it. Okay, let us say I'm having two sets. It is having a set fuzzy set. It means what? Why it is written 1 and below 2? It means for data 2, the belongingness is 1. For data 3, the belongingness is 0.5. For data 4, the belongingness is 0.6. So this is how it is being represented. This is how it is represented. Okay. So for all the data, I got these values. I got these values. So I want to do the operation. Let us say A tilde union set B. So what is the formula? The formula is what? Maximum of what? Membership in set A for value X and membership of element B for the element X. This is how I'm going to find. Okay, this is how I'm going to find. So what will be the value? So the result, let us say, let me write C tilde as the result, C tilde as the result. So for data 2, I need to find, for data 3 I need to find, for data 4 I need to find, for data 5 I need to find, and for data 6 I need to find the membership. So out of these two, 0.5 and 1, which one is maximum? 1 is maximum. 0.8 and 0.5, which one is maximum? I got 0.8. Okay, then 0.4 and 0.6, which one is maximum? I got here 0.6. Okay, then 0.7 and 0.2, which one is maximum? I got 0.7. Similarly, 0.3 and 0.6, which one is maximum? 0.6. Now when I am taking union, so this is the value I got. So this is how the max function is used. This is how the max function is used. Let us try to do other problems like so a union B. So if I want to find complement, it is 1 by 2. No, it means for data 2 the belongingness was 1, so it reduced to its complement means 1 minus the value 0. This becomes 1, so this becomes 1. So this is the value. For this value it was 0.5. 1 minus 0.5, 1 minus 0.5, it becomes 0.5. So similarly for both the set I found, and this is the value already I have told you. Okay, this is the value I have already told you how to find union. Similarly, let us try to find the other operations also. So intersection is, the formula for intersection is what? Minimum of what? Membership value in set A for the data X, comma, membership value for this in the set B for the data X. This is how the minimum will be found out. Okay. So with the previous data, this is how I'll be finding the minimum. This is how I'll be finding the minimum. Okay. Now for difference. Difference means what? Difference is nothing but A intersection. The general logic you see. This is my set A and this is my set B. Okay, this is my set B. A minus B what? This is the reason. This part is my A minus B. This part is my A minus B. It means I am rejecting A intersection B. I am rejecting A intersection B from A. It means A intersection A is what? Prime. So this is how. So intersection how to do? By using minimum operation. Similarly, B intersection or A also you can find. B intersection A also you can find. Okay. So you can apply De Morgan's law and all this things. Similarly, you can have different problems. Let us try to go back to writing of the programs. I hope you understood this, and let us write few programs so that you will be able to understand these operations, how to write it. Okay. So let me write first of all what if you are having some kind of Python knowledge, it will be easy to understand. But otherwise, I'll help you out. Okay. So we are doing what the operation of union. We are doing union operation. For this, you need, let us say, variable A, and this is a dictionary I want to take. It's an empty dictionary. Similarly, B, I'm taking one more dictionary, and the result C, I'm taking this one more dictionary. What is a dictionary? Dictionary is a special data type. It is available in Python that carries data like your general dictionary. Like I'll write for value A, let us say the belongingness is 0.3, and for data, let us say B, the belongingness is, let us say 0.8. Okay, for data C, separated by comma. Okay, for data C, let us say the belongingness is 0.1. Okay, and let us say for data D, let us say the belongingness is 0.5. Okay. Similarly, this is the value. This is what data I got. So you understood what is a dictionary. For this particular value, what is the belongingness? I can write. Similarly, I can this and change the values. Change the values. Let us say for A, I am having, let us say 0.6. For B, let us say 0.2. This is 0.9, and this is 0.5. Let us say. Uh, Share attendance. Okay. This is my set B. This is my set B. So in a dictionary, basically, the first one, is it properly visible? I'll increase the font. Let me increase the font little bit. So that,
Yes,
okay.
sir.
Okay, sir.
So is it okay now? So A and B I got, and I want to save the union of these two, and I am writing for, let us say, two variable I'll take. Let us say A's key, and I'll take B's key. I'll just let me write it down, then I'll explain you. Uh, in if of A comma B, okay, then what variable I've taken? A key equal to A's A key, and this is A value. This is A value, and I'm having B's key, B's value, B value is equal to what? B's key. I've taken these data. What is that? Okay, and I'm taking please. Oh, I'm taking the if. What is that if? If A's value, if A's value is greater than B's value, if A's values is greater than B's value, then I'll write this C. C is what? A key is
You are not audible, sir. Sir, you are not audible.
Audio and video is not coming.
Sir has left the meeting. I think there is a internet connection problem. There is.
Doctor,
Sir,
please share attendance link so that we can utilize our time.
definitely, sir. What is happening? Don't know.
దేశమంతా మొదలైపోయింది. అటువంటప్పుడు కేవలం అత్యవసరాల కోసం మాత్రమే ఇంటి నుంచి బయటకు వెళ్ళాలి. ముఖంపై కవర్ లేదా మాస్క్
Sir is trying to log in again. He was disconnected due to the internet problem. So if I request to everyone, please open their camera so that we can capture one photo. Meanwhile,
sir. Am I audible?
yes, sir, you are audible, sir.
Sorry, sir. I got disconnected.
Okay, sir, we are
So
just,
is my screen visible now?
sir, we are just taking one picture. With our all
Okay.
participants.
Sure.
So I have requested everyone to please on their camera. Okay, we have taken, sir. Please share your screens.
Okay. Okay. So we are halfway, and we are writing B's value. I think my screen is visible now.
Yes, sir, it is visible.
Pankaja is now. Pankaja, I think, is sharing.
Pankaja, okay,
Pankaja,
okay.
ma'am, please don't share.
Yes, sir. I'm sharing my screen.
Okay. I think what share. Are you able to see my screen? I think no. You are able to see my screen? No, no? Vijay sir, are you able to see my screen?
No, sir.
Oh, wait, I'll log in once more. I'll log in once more.
Pankaja ma'am, please stop sharing your screen.
Okay, sir. Okay, sir. Thanks. Sir, shall I switch off the video also, or you need?
Yes, ma'am. Yes, ma'am. You can.
You can. Thank you, sir.
Rakesh sir, please share your screen, sir.
Yeah, I'm trying. Because, some net issue is there. Yes, okay. Is my screen now or visible? I think it's okay. So
Yes,
this
sir,
is what,
visible.
and then yeah, then I can write.
Now it is visible, sir.
Fuzzy. Thank you, sir. Fuzzy union is, I can something like C. Before that I can write. Before that here I can write. This is A. G set 1 is A. For the set 2 is B.
Hello.
And the union is C. So I can write like this. Okay. Now let me explain you what it is. There is a data type dictionary. There is data dictionary.
आप किससे बात कर रहे हैं?
It takes,
हैं?
it takes two values.
नहीं. तो सोनभद्र से हम बात कर रहे हैं, विजय से.
Vijay sir, unmute कर दीजिए ना. Okay. So it takes two values, like A. The first part is called key. This first key, and the second part is called value. The second part is called a value. Okay. So for this particular key, this particular value. So and in any dictionary, if you see general meaning also, whatever dictionary you are having. For your, let's say, your telephone directory, or let us say your word is in the English dictionary, the same word doesn't repeat, isn't it? I mean, for same value, two times they don't write the meaning of same word. Like that, the key will never be repeated. The value may be repeated. Okay, so this is what a dictionary in in Python. So I have defined a dictionary for A. I mean, according to me, it is data, and for this data, this is my belongingness. Okay, for this particular data, this is my belongingness. C, this is the belongingness, and for D, 0.5 belongingness. This is how I have defined set A. Similarly, I have defined set B. So whatever I told, exactly same thing I have written in this code. What is that? I have taken this is a value, access the data like an array in C. For the A, the value is 0.5. For I mean, for what dictionary A, if the data is passed, the value will be 0.3. The value will be 0.3. So this is what I have done. I have assigned the data. Okay, I've assigned the data. And the next thing is the logic that I told. If A's value is greater than B's value, then I'll put in A's place, I'll put is there any problem?
Rakesh sir.
Yes.
Sir, screen is not
Is there any
visible.
problem?
It is not visible, sir.
Array, you are. It is showing you are presenting. It is showing me you are presenting. I'll stop presenting once more. I'll stop presenting and I'll do it once more. Okay. Now I think it is visible. Is it visible now? Vijay sir?
Yes.
Okay. Now let me.
Yes, sir. Visible, visible.
Now let me. Thank you, sir. Let me save this code first. Let me say, let us say fuzzy one or fuzzy union I'm writing, and I can execute it. You see, these values are there. Out of these two, whichever is greater, it is being printed. Out of these two, whichever is greater, it is being printed. Out of these two values, whatever is greater. This is how I perform a union operation. In the same way, I can have intersection operation simply by something like this. Okay, if I change greater than to less than, I'll be getting the intersection operation. I'll get the
Again, there is a network problem. So
sorry, sir. There are frequent net problems there.
yes, sir. Yes, sir.
So
We
I'm
can
getting
we can
disconnected.
understand, sir.
Okay.
Anyway,
So I can. This is the program. I'll show you once, so that all the what operations that we discussed, that it will be clear. Yeah. So union operations, I have already told you that greater than symbol will be there. For intersection, I'll show you that less than symbol will be there. And for fuzzy, I'll be writing like this only. Okay, it means 1 minus the value if I do, I'll get. And for what difference, it is like, I mean, very easy. I'll do 1 minus this value, and then I'll do yeah, intersection operation. I'll do intersection operation. Okay, so this is what it's all about that I wanted to discuss today.
sir.
Uh,
So with this, we are going to end this session. But before that, Are you going to present, sir?
No. I was just concluded that thing. That's why.
Okay. So we have some questions in our chat box.
Okay. Tell me, sir.
Uh, the is there a limit on the member of output membership function of fuzzy logic controller? Can we
Uh,
use 100 membership function?
Yes. Because look, most of the thing, whatever fuzzy controllers that we are using nowadays, let us talk about a kind of a a sensor you are taking. Okay, you are receiving the data from a sensor. So generally, sensor how generally will be emulating. You will be taking a Raspberry Pi or a kind of a IoT kit, right? So when you are taking, it is a computer by itself. It is a computer by itself. It is having RAM. It is having memory. Of course, if you don't have much kind of a storage, it processes and give the data out. So you can have as many like if you want to have a 4 GB RAM for a like a IoT kit, you can imagine how much data you can process at time. So basically, it depends on the RAM and the processing power of the system that you are taking. So virtually there is no limit. Is there any other question, sir? Vijay sir, is there any other questions?
Sir, what is the best way to develop a fuzzy logic rule base of a fuzzy logic damping controller for fax device applications?
Actually, every system, every expert system that you are designing, for every expert system, there is a rule. And the rule based on the scenario. As I told you, like hotness in India, let us say like 40 or 40 degree, 42 degree, it is okay, little bit hot we can bear. But if that 40 or 42 degree, some foreigner comes and he has to face that particular temperature, then it is unbearable for him, isn't it? So that's why the fuzzy control or fuzzy logic, whatever you are utilizing, it depends on the scenario, even it depends on the geographical location also. So the rule basically changes based on the scenario where you are going to deploy it. Okay, so that's why you cannot concretely say that this particular rule only I'll be applying. Now, what is one more question is what are the advanced research area in artificial intelligence machine learning? Look, madam, now it is you can say people are right now working. You name a area where artificial intelligence machine learning is not used. Everywhere you need to find a application kind of thing. You even in chemical engineering, when you are testing the pH value of a particular liquid, you need a sensor if the pH value is frequently changing, and for this way pH value you want to treat it in this way or that way. Based on that, what you are going to take a decision based on the value pH value of the particular liquid, isn't it? So ultimately, you are making the system learn by itself. When you are talking about artificial intelligence, you may be having supervised learning or unsupervised learning or reinforced learning, isn't it? So whenever it comes to learning kind of concept, there must be a rule of learning, right? And whenever the rule of learning, the way you make the rule, depending on that, the expert system will be learning and accordingly it will be performing. Okay. So if I'll name one or two area of application of artificial intelligence and machine learning, it will be really unjustified to ignoring others. Now the total world, you name it, you can apply. You name the area, you can apply artificial intelligence in that. Just you need to open your eyes and look at the world, that how can you apply artificial intelligence. And fuzzy logic is inbuilt, it has to be there when you are talking about artificial intelligence. Whenever you are talking about artificial intelligence, obviously you will be talking about either optimization, or you are talking about decision making, right? Decision making. When it is talking about decision making, obviously some kind of if then else kind of situation will come, and it is nothing but fuzzy logic. And when the data you are giving is continuous data, it is not a discrete data, so obviously you are using fuzzy logic.
Okay. Thank you so much, sir, for giving informative talk on the fuzzy logic in an applications. Sir, I've started with the basic definition of the fuzzy logic. It's the applications, and also have shown uh, the some problem through the Python coding. Once again, thank you so much, sir, for spare your valuable time
Thank you, sir. Thank you very much.
from
It
your
was my
busy
pleasure.
schedule for this FDP. Once again, thank you so much, sir.
Thank you, sir. Thank you, Big Man.
Thank you, sir. We will again resume at 12 noon, and the speaker is from IIT BHU, Dr. Vivek Nandan Lal ji, and the topic of his presentation is the PV forecasting by ANN. Thank you.